Hello everyone, today we'll solve some problems from Randall, 25 chapters. That's our first problem. Let's read this problem together. A 2 mm diameter glass bead is positively charged. The potential difference between a 0.2 mm from the bead and the 0.4 mm from the bead is 500 volt. What is the charge on the bead? So, to solve this problem, first of all, let's visualize this problem. So, it is said that we have 2 mm diameter glass bead and 2 mm apart from the bead we have first potential, and from the 4 mm from the bead we have second potential. And we have diameter of this glass bead, it is 2 mm. We have potential difference, it is 500 volt. And we should find charge. So, let's remember the formula of potential. It is V equal Q over R. And the formula of potential difference, it is V1 minus V2. Maybe you will have question why V1 minus V2. So because let's look the relationship between potential and the distance. They're inversely proportional. If our distance will be increasing, our potential will be decreasing. Or maybe if our distance will be decreasing, our potential will be increasing. So that's why in our case V1 minus V2. Now let's write the formula. So, and in this formula, we will calculate the distance from the center of the bead. That's why radius of the bead, it is important. So, car Q over R plus 2 millimeter minus car Q over R plus 4 millimeter. This R, it is radius. Now let's summarize this formula. This Q 1 over 3, because our radius is 1 millimeter. It will be 5 millimeter. So car Q multiplied, it will be 15 millimeter in denominator, and 5 minus 3, it will be 2 millimeter. Our millimeters will be reduced. Now let's find Q from this formula. It will be potential difference multiplied 15 and 2K. So let's just put the formula. Let's just put the numbers for this formula and solve it. So if we calculate this, at the end we will be find our Q. It will be 416.7 nanocoulombs. So find our charge. It is 416.7 nanocoulomb. Now let's solve another problem. It is interesting problem. So let's read this problem together. Two small metal cubes with masses 2 gram and 4 gram are tied together by a 5 centimeter long massless string and are at the rest on a frictional surface, each is charged to plus 2 millicoulomb. And we should find energy of the system, tension in the string, and at the C part, we should find speed of each cube when they are far apart. And we have in there two conserved quantities, make use of bus. So, also to solve this problem, let's visualize this problem first of all. So, it will be before and after. So, it is 2 gram, it is 4 gram, and we have 5 centimeter long massless string. And A part we find energy of the system. So to solve this problem, let's remember conservation of laws. We will use conservation of energy. Initial kinetic energy plus initial potential energy will be equal energy of the system as mechanical energy. And it says that before the string was cut, there was the rest on the frictional surface. That's why our kinetic energy will be 0. And our energy of the system will be equal to potential energy. And we know that potential energy equals to car Q1 multiplied Q2 over R. So it will be equal to energy of this system. You will just need put the numbers to this formula and solve it. At the end, you will get that number. 0.72 joules. Now, let's solve C part of this problem. Oh, B part. Sorry. In B part, we should find tension. So, let's consider that is x-axis, and their status, they're both there's same charges. So, they're same. That's why they will repel each other. Their coulomb force will be at this direction and tension will be at this direction. So at x-axis we have coulomb plus tension, it will be 0, and it will equal tension. So we find the tension because we know the Coulomb's law. It will be K multiplied Q1 multiplied Q2 over R squared. All this, we have all these numbers, magnitude of all this stuff, and we just put the numbers and calculate it. Believe me or not, the tension will be 14.4 newtons. Now let's solve the C part of the problem. The string is cut. What is the speed of each cube when they are far apart? For this C part, we will use conservation of laws. First of all, let's see our conservation of energy. it will be initial kinetic energy plus initial potential energy equal final kinetic energy plus final potential energy. Our kinetic energy will be 0. Final potential energy will be 0. We know our initial potential energy. Yep. And our final kinetic energy will be m v1 squared over 2 plus m2 v2 squared over 2. So we don't know v1 and the v2, that's why we'll use momentum formulas. In this problem, momentum also conserved. That's why we will use this formula. M1 multiplied v1, m2 plus m1 v1 plus m2 v2 equals 0. From this formula, we will find v1. It will be minus m2 v2 over m1. We will put this v1 to this formula. So our initial potential energy will be m1 over 2 multiplied it will be 2 square v2 squared over m1 squared and m1 squared. There will be reduced, it will be plus m2 v2 square over 2. Now from this formula, let's find v2. Let's summarize this. M2 multiplied v2 square over 2. It will be m2 over m1 plus m no, it will be just 1. Yeah. From here we'll find v2. It will be 2 multiplied initial potential energy over m2 multiplied m over m1 plus 1. So you will just put a number to this formula and you will find v2. Then you just will put the v2 to v1 formula and you will find v1 and v2. So our second problem also solved. So thank you for attention.